Voyager 1, NASA's farthest traveled spacecraft, continues its remarkable journey through space, dutifully transmitting invaluable data from the deepest regions of the cosmos. For nearly 5 decades, this extraordinary space probe has revolutionized our understanding of outer space. However, recently the spacecraft has been transmitting alarming data back to Earth, leaving the entire space industry in shock. Are these scary data the result of a technical malfunction or the activities of extraterrestrials? Join us as we uncover the truth behind these shocking transmissions. Since the dawn of time, scientists have been captivated by the mysteries that lie beyond our celestial borders. This curiosity led to the groundbreaking launch of the Voyager 1 and Voyager 2 spacecraft, among other remarkable space missions. These missions started with the launch of Voyager 2 from the illustrious NASA Kennedy Space Center on August 20, 1977. 2 weeks later, on September 5 of the same year, Voyager 1 followed suit. These twin probes, each weighing a substantial 720 kilograms, equivalent to that of a small car, were propelled into space during a unique alignment of the outer planets. Throughout their incredible odyssey, these intrepid explorers navigated diverse trajectories and speeds. A pivotal moment occurred on December 15, 1977, when Voyager 1 surpassed its identical twin owing to variations in their paths. Since then, Voyager 1 has become an invaluable resource, providing us with an abundance of knowledge and unraveling space-related mysteries. Before we delve into Voyager's terrifying new discovery that shocked the entire space industry, let's explore the remarkable images captured by the spacecraft during its groundbreaking Jovian imaging mission. In 1978, Voyager 1 was stationed approximately 265 million kilometers from Earth. From this vantage point, it transmitted a staggering number of photographs back to Earth. In January 1979, it embarked on an extraordinary 100-hour endeavor, capturing a mesmerizing time-lapse movie showcasing 10 rotations of Jupiter. A cornucopia of 3,750 images allowed us to witness Jupiter's majestic dance in vivid detail. In the subsequent months, Voyager 1 ventured through the Jovian moon system, where it made a remarkable discovery: the presence of a diminutive ring encircling Jupiter. Additionally, 2 new moons, Thebe and Métis, were brought to our attention, further expanding our understanding of Jupiter's enthralling realm. To ensure a safe passage and prevent a potential collision with Titan, one of Saturn's moons, corrective maneuvers were executed. Voyager 1 continued its celestial voyage around Saturn, uncovering 4 additional moons: Mimas, Enceladus, Tethys, and Dione. With the completion of the Saturn mission, scientists decided to propel both Voyager 1 and Voyager 2 beyond the confines of our solar system, hurtling through space at an astounding speed of 325 million miles per year. In January 1990, a new chapter commenced: the Voyager Interstellar mission. During this phase, Voyager 1 produced some of the most iconic photographs in history, immortalizing the Sun and the majority of the planets. One individual who played a pivotal role in extending the missions beyond their initial objectives was the eminent astronomer Carl Sagan. As a member of the Voyager missions team, Sagan ardently championed the idea of capturing one last set of images, a farewell gift to humanity. Against all odds, his unwavering determination bore fruit on February 14, 1990. Voyager 1, positioned 6 billion kilometers from the Sun, embarked on a photographic journey, capturing what is widely known as the Solar System Family Photo. These breathtaking images, totaling 60 in number, added to the spacecraft's impressive collection of 67,000 photographs. During its encounter with Neptune, Voyager 2 achieved an extraordinary feat. It recorded wind speeds surpassing 1,000 miles per hour, making it the fastest wind ever documented within our solar system. As the spacecraft ventured within 280 miles of Neptune's azure methane-rich atmosphere, it bestowed upon us unprecedented insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was unveiled as one of the coldest locales within our solar system, with surface temperatures plummeting to a bone-chilling -391 degrees Fahrenheit. Triton's strange features, such as its nitrogen gas-spewing ice volcanoes that propelled icy particles 5 miles into its tenuous atmosphere, further captivated our imaginations. These extraordinary discoveries expanded our understanding of the immense diversity and intricacy of celestial objects residing in the farthest reaches of our solar system. Don't go anywhere. The Voyager 1 spacecraft has recently made one of its most terrifying discoveries. But first, let's review what it has achieved in the last 45 years. The achievements of the Voyager twin probes have been nothing short of extraordinary. More than 4 decades ago, their early observations of Jupiter and Saturn's moons left researchers in awe and shattered previous assumptions about these remote worlds. These moons, once thought to be inactive and heavily pockmarked like our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, achieved several remarkable milestones during its voyage. It made history in 1986 by becoming the first spacecraft to fly by Uranus, and just 3 years later, it accomplished another groundbreaking feat with a flyby of Neptune. To this day, it remains the sole spacecraft to have embarked on such a path. As the Voyager spacecraft continued their journey, NASA implemented various measures to prolong their operational lifespan. Over the past 3 years, non-essential components and heaters have been deactivated to conserve energy, ensuring that these intrepid explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this extraordinary endeavor from the very beginning, the culmination of the Voyager missions is both a moment of pride and a touch of melancholy. Their unwavering dedication and tireless efforts have far exceeded their initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, fueled numerous scientific discoveries, and sparked the imagination of countless researchers and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary spacecraft. They were meticulously designed as stable platforms, with a rotation rate over 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the spacecraft captured images and data while hurtling through the vastness of space. Even before their encounters with the outer planets, their impressive imaging capabilities began to amaze scientists and the public alike. The spacecraft began transmitting images of Jupiter several months before reaching the gas giant. These early images, showcasing the swirling clouds and iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected peculiar signals from Io, which were confirmed by the vivid images they captured. Towering volcanic plumes and a surface scarred by volcanic material ejections were unveiled. Pele, one of Io's most prominent volcanoes, has erupted with a force 30 times greater than Mount Everest's height, covering an area nearly the size of France. While the spacecraft's cameras were ultimately powered down to conserve power and memory before their journey into interstellar space, it is worth noting that the photos they captured did not include Mercury and Mars for various reasons. In addition to the Voyager 1 and Voyager 2 interstellar probes, NASA has also operated other notable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed by Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Voyager 1 continued its solitary voyage for another 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to catch up with, NASA did not publicly announce this remarkable achievement until 2013. In the legendary Voyager missions, one technique stood out as truly brilliant: gravity assist maneuvers. These maneuvers played a crucial role in propelling Voyager 1 and Voyager 2 on their audacious quest to explore the outer reaches of our solar system. In order to reach these distant destinations and gather invaluable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assist provided just that. Imagine the two intrepid spacecraft, Voyager 1 and Voyager 2, embarking on their grand tour of the solar system. Instead of relying solely on their engines, they engaged in a celestial dance with some of our solar system's heavyweight planets. This intricate choreography allowed them to utilize the immense gravitational pull of these giants to slingshot themselves on their way. By doing so, They conserved precious fuel and gained the velocity required to visit multiple destinations. Performing a gravity assist maneuver requires extraordinary precision. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation. In order to accomplish this, the flight team meticulously calculated the spacecraft's trajectory. They predicted its path, accounting for the gravitational influences of each planet along the way. The culmination of years of preparation and precise calculations culminated in success. The gravity assist maneuver was a triumph of engineering ingenuity. Voyager 1 and Voyager 2 capitalized on the gravitational pull of 4 planets in their grand tour of the solar system. Their first gravity assist took place during their encounter with Jupiter, the largest planet in our solar system. This was followed by a visit to Saturn, with its majestic rings and intriguing moons. Voyager 1 performed an additional gravity assist maneuver as it journeyed past Saturn's largest moon, Titan, a thrilling encounter with Uranus and its 27 moons, and finally a tantalizing flyby of Neptune, a planet whose atmosphere features a range of bluish hues. After launching from Earth, Voyager 1 and Voyager 2 embarked on their ambitious journey toward the outer planets. Their success hinged on several key strategies and technological innovations. 1. Trajectory planning. The flight paths of Voyager 1 and Voyager 2 were meticulously planned to optimize their encounters with multiple planets. This included precise calculations of when and where to perform gravity assist maneuvers to achieve the desired trajectories. 2. Gravity assist maneuvers. As mentioned earlier, gravity assist maneuvers played a pivotal role in the Voyager missions. By carefully flying close to massive planets like Jupiter and Saturn, the spacecraft utilized their gravitational fields to gain speed and alter their trajectories. This allowed them to reach farther into the outer solar system than would have been possible with their onboard propulsion alone. 3. Longevity and redundancy. The Voyager spacecraft were designed with longevity and redundancy in mind. They were equipped with redundant systems to ensure continued operation even if some components failed. This robust design has allowed Voyager 1 and Voyager 2 to continue functioning decades beyond their original mission lifetimes. 4. Data storage and transmission. The Voyager probes were equipped with sophisticated data storage and transmission systems. They used onboard digital tape recorders to store scientific data, which was later transmitted back to Earth. The data transmission rates were relatively slow compared to modern standards but sufficient to send back valuable information about the outer planets and beyond. 5. Scientific instruments. Both Voyager 1 and Voyager 2 carried a suite of scientific instruments designed to study various aspects of the planets and their moons. These instruments included cameras for imaging, spectrometers for analyzing compositions, magnetometers for measuring magnetic fields, and plasma detectors for studying charged particles. 6. Navigation and course corrections. Throughout their journey, the Voyager spacecraft relied on accurate navigation systems to maintain their course and orientation. Small course corrections were periodically made to ensure that the probes stayed on target for their planetary encounters. 7. Deep Space Network. DSN. NASA's Deep Space Network played a crucial role in communicating with Voyager 1 and Voyager 2. This network of ground-based antennas, located around the globe, allowed continuous communication with the spacecraft even at vast distances from Earth. 8. Interstellar mission planning. After completing their primary mission to study the outer planets, Voyager 1 and Voyager 2 embarked on their interstellar mission. This phase involved preparing the spacecraft for operations in deep space, beyond the influence of the Sun's magnetic field. It included optimizing power usage, shutting down non-essential systems, and preparing for long-term data transmission back to Earth. The combination of these strategies and innovations enabled Voyager 1 and Voyager 2 to achieve unprecedented success in exploring the outer solar system and beyond. Their discoveries have revolutionized our understanding of planetary science, astrophysics, and the nature of interstellar space. As these venerable spacecraft continue their journey into the unknown, they remain a testament to human ingenuity, perseverance, and curiosity about the cosmos.